Steve, good kia ora, everybody. Good morning, everybody from around the country. Edwin and I were going to make a claim that we are the most northerly and southerly participants in the room today. I'm based down in Mosgiel, just over the hill on the southern motorway from Dunedin, and Edwin's up in Kaitaia. I'll get into Edwin to introduce himself in just a moment. Even if I'm not the most southerly, I'm going to claim I'm the coldest participant. It's currently minus 1.3 in Mosgiel, but it is a beautiful day. But the frost is yet to clear.
Very much following the way the 2006-7, depending which edition you want to look at.
I've got a few. There's a bit of noise coming through, Steve. I'm not sure if everybody else is on mute there.
Okay, that noise has now stopped.
Okay. Hey, perfect. Well, kia ora. This is our welcome slide, and it's just thanking and acknowledging Steve and the AMA and NZAMT and everybody who's put together these mornings. I've certainly in previous roles in the classroom come to these for 2 years on the trot and enjoyed every single one. And it's feel very lucky to be presenting today and sharing some ideas from our new role in the ministry and trying to help everybody. My role in the ministry is the learning area lead for mathematics and statistics, and I've deliberately put my email and mobile number there, and Edwin can introduce himself in just a moment. But when I was up and we were helping at the Auckland HOD's Day on the 19th of May, Pip made it very, very clear that we really want to just sort of open our arms out, and with all these changes coming our way and rolling through in the next 2, 3, 4 years, that we want to be available, we want to be a face, we want to be helped, we want to be there to help at any point. So our mobiles are there and our emails are there to be contacted at any time. And actually in the last 2 weekends out of 3, an HOD has actually rung me up on my mobile just to really sound apologetic at the start. And I said, don't worry. And they just wanted some help for a faculty meeting they were leading on the Monday. So we really just want to emphasize we are here to help. We are available, not quite 24/7, but you've got our contact details there. So please take advantage for good professional reasons. Edwin, introduce yourself, my friend.
Kia ora koutou, ko Edwin Small toku ingoa. Greeting you from the sunny far north, where it's a balmy 13 degrees in Kaitaia. My role in the ministry is one of the NCEA implementation facilitators, or NIFs. Those of you who love acronyms will know that we're full of acronyms, so I'm a NIF. And if it is one thing I want you to take away from this introduction, really, is there is no wrong door to access me and my support. You can get me through Mark, you can get me through any of the curriculum leads, or my email address and my mobile number are right there on the screen as well. So I am responsible for the Tutairaro Takiwa, which would be from Auckland all the way north. So feel free to access me, as I said, anything to do with the NCEA changes in general and the impact on math and stats in particular. Over to you, Mark.
Okay, thank you. And hey, look, we've split our presentation. Edwin will take over and lead about halfway through at 12:30ish for the last 15-20 minutes to share an idea across the curriculum that he's got there. But just before we get into the meat of the presentation, this has worked really well in presentations I've done. It seems to have worked really well in presentations I've done over the last couple of years with some advice from NZAMT. And if you do link onto that URL there, I've just simplified the URL. It is a Google form, but if you want to ask any questions about any of the changes, please just click on that URL there. tinyurl/AMA-10th of June. It does link to a Google form. You can ask some questions in that Google form. And if we can't answer them today, we'll certainly get some written responses and get them back to Steve and Anne and the wider AMA and NZAMT to share in the next week or two. But before you ask any questions, I'd perhaps suggest if you link on this tiny URL, tinyurl.com/already asked, I actually have been doing quite a lot of travel over the first part of term 2, and particularly in Tauranga, Auckland, and most recently in the Wairarapa. Questions have previously been asked and answered, although I have stuffed up with the Wairarapa one. That tiny URL there links to a folder which has 3 PDFs contained in it. And the Wairarapa questions have the questions, but not the answers, because on the presentation day itself, I answered them verbally. So I'll probably make an effort, hopefully on Monday and Tuesday, to get those answers written up. So if you've got a burning question about the changes and the curriculum and the assessment changes, may just pay to look at the questions which have already been asked and hopefully already answered in that second URL there. Okay, and of course you can interrupt at any point today with a question in the chat. Maybe Edwin, in your half, if you could keep an eye on the chat if there are any questions that have come through, if that's all right, and I'll swap over when you lead the second half. What we're trying to achieve today with us all in the room is in the first part, it's a quick run through because we're here for just about another 40 minutes or so. I just want to do a little bit of an example way of breaking down the new curriculum, the refreshed curriculum, the 5-phase curriculum that was dumped and finalized in May, just a couple of weeks ago. In the second part, I just want to share an example, and it's not the way to construct a course for 2024. And I want to give credit for a good mate who's head of maths at Hamilton Girls. Hannah Reid has shared with me her thoughts on how she's constructing the courses for 2024 for level 1, and it's captured me in a really positive way, and it's been worthwhile sharing at a couple of the engagements I've done already. And then Edwin and I, each with our, at the end of the day, passionate maths teachers hats on ourselves. In the third part, I want to share a statistical activity based on that side of the curriculum, the current level 6 in the probability and statistics side of the curriculum, leveraging into the new refreshed curriculum as well, which eventually will lead to a potential assessment against the 1.1 explore data. And this has actually been inspired by sharing and linking with some of the pilot schools and perhaps some of the positive frustration that they're feeling about that I think they've developed enough expertise that they're just ready to burst free in 2024 and write their own assessment activities. And I think there are some feelings out there that the pilot schools are a little bit constrained in this pilot year because they're forced to use particular assessment activities, the ones up online. And a couple of them have got in touch, not in a critical way, but they're just ready and bursting to get going next year when they can write their own assessment activities. But I want to come from a teaching and learning activity there, and I'm going to focus on time series. Time series is particularly unique within the new refreshed curriculum and the new assessments of learning. So I'll just show an activity there, which hopefully may plant some seeds. And then in part 4, just to end up with, Edwin will take the other half of that same coin and do I've had a lucky chance to look at it before he shares it with you, but a mathematical activity based on what you would do potentially from a course of learning in 2024, which is trying to link as many strands together. Okay, so a big aim of the changes we know as math teachers is we want to stop this siloing and breaking stuff down into discrete blocks. We want to make the connections and teach the subject as a coherent body of knowledge. So Edwin's got a fantastic activity to show that. I am going to skip through a number of slides now because they're very texty and it would take too long to go through, and they just sort of help break down how the new curriculum works. But this is going to be shared through AMA's website, so you can come back to this presentation. So I'm literally going to squiz through about 10 slides and get through to the point where I would just want to exemplify an example of how the new curriculum works. So there's some stuff in here to do with the common practice model, and there's more support to come, but I wanted to land on this slide here. And I was aware in the first 2 weeks of term 2, we'll remember that we had that teacher only day window, the 9 days, because one of the 9 days was Anzac Day, of course. And I'd actually had 2 phone calls from heads of maths around about right at the start of term 2 saying, I've looked at the refreshed curriculum that was up online at that time, and I'm pretty horrified, Mark. I'm paraphrasing here and I'm probably misquoting, but it's getting the point across. I'm a little bit scared that I'm reading the new curriculum, Mark, and this was the quote: Pythagoras is in, but trigonometry is out. And I can absolutely walk a mile in the shoes of my colleagues and mates who rang me up at that time and say, well, I can understand why you think that reading the new refreshed curriculum, but it's actually not correct. And so I just want to exemplify and show how we can unpack how we use the new curriculum and how it links at senior secondary with our learning matrices, which are up online. And then I'll get into an exemplar way of course planning. So this understand, know, do columns we see are actually from phase 4. And I've just highlighted in green a couple of sections there, and I've blown them up so we can read them on the screen today. I think, first of all, we'd acknowledge it would be horrible. We'd all be horrified if trigonometry was literally taken out of the New Zealand maths curriculum and our students were not going to learn it through to the end of senior secondary. But at the end of phase 4, year 9 and year 10, those two green highlighted sections really exemplify and explicitly say, hey, by the end of year 10, we want our kids to be knowledgeable, confident, competent at knowing and using Pythagoras theorem. And I think by the end of year 10, by the end of phase 4, we would all be really happy with our students knowing and being confident at Pythagoras theorem. The next understand, know, do columns are from phase 5, and I've kept that same statement my colleague rang up with at the start of term 2, Pythagoras is in, but trigonometry is out. And similarly, the two green highlighted sections there in the I know that and I know how to subcolumns under know, they are blown up to say a point on a unit circle and dealing with trig identities. And I'm pretty sure by the end of year 13, if a student decides to study a course of mathematics through to the end of year 13, we would be happy that students would be confident at polar coordinates on the unit circle and happy at dealing with, we'd be happy if they were dealing with and confident and knowledgeable and happy and seeing the use of trig identities, including that one there that's exemplified, probably the most famous and one of the most useful ones. But I would further argue to get to that point by the end of year 13, we would want them to be good at right-angled trig. They're only going to get to that stage about being confident on the unit circle and polar coordinates. They're only going to be good at dealing with trig identities if they are good at right-angled trig. And so that statement there on the right-hand side is from our year 11 current level 6, because we're still officially against the current curriculum in our level 6, 7, and 8 at senior secondary. From the year 11 level 6 learning matrix, we've got that statement on the right-hand side, which I hope to us all does speak and scream, yep, that's right-angled trig. There are some rules at the ministry, the teams that are ensconced writing these statements, they weren't allowed to use the word trigonometry explicitly because it's considered a term which is too all-encompassing. Trigonometry doesn't just sit at the start of year 11, 12, and 13. It goes through all of those 3 years, all of phase 5 and well beyond, as we know. So, but I'd hope we'd be happy that on the right-hand side, in order to get to that stage by the end of phase 5, the unit circle and the trig identities, at the first step in year 11 on our learning matrix, it's pretty explicit that we're talking about right-angled trig on the right-hand side. So it's actually not true what my two mates rang up at the start of term and said, look, I'm horrified, trigonometry isn't anywhere in the curriculum, the stuff that we teach in year 10 and year 11. But actually it is. It's getting used to linking the refreshed curriculum with our learning matrices, which have been up on the website nca.education for some time now, okay? And it will be the learning matrices through year 11, year 12, and year 13 that do step the learning up to that statement by the end of phase 5. It does raise another question and a bunch of questions which have come through from colleagues in the country. Do we have to teach trig? Now we're satisfied trig is in the curriculum and we're still teaching right-angled trig. Does that mean we teach it at the start of year 11 because it appears in the learning matrix at year 11, which is at the start of phase 5? Well, absolutely not. I mean, it's not a controversial thing to say. I hope that most of us probably do teach Pythag and trig through to the end of year 10. Remember that the statements associated with phase 5 are by the end of year 13. Well, by the end of year 13 means you can still teach something in year 10. So that doesn't stop you teaching trig and Pythagoras in year 10 to make sure that students who study mathematics through to the end of year 13, by the end of year 13, have covered all the knowledge and content and ideas they need to. There's a very interesting statement at the start of the curriculum, at the front end of the new curriculum, and it's the one that I've just highlighted in blue there. And I'm personally translating that statement as, I'm really looking at the word ambitious in the middle of that top line that's been highlighted. And I'm personally translating that as if stuff is actually in phase 5, but your students, your community, your classes are ready to have it shared and taught with them at an earlier phase and an earlier year level, then do that. Okay, so that's a statement that I think is actually, yeah, as I said, on the very first few pages, the front end of the refreshed curriculum for mathematics and statistics. Going at a bit of a pace here, sorry guys, just with the time. I just wanted to, I don't need to, you can refer to that texty slide. There is an activity which, this is the last time I'm going to share this, because this was shared in Tauranga, Auckland, Wairarapa and Christchurch, up in Christchurch earlier this week with some colleagues. But we have developed a resource in the team which will help teams, I hope, construct courses. You can see a screenshot there of term 1, 2, 3 and 4 and some blue, green and red cards. Blue is number and algebra, green is geometry and measurement, and red is probability and stats. And each of those text boxes on the right-hand side contain a statement from the level 6 year 11 learning matrix. So that one at the top right is make predictions within the data range for bivariate data. There are two more lines in the text box there. The bottom line refers to the assessments of learning, the new achievement standards that can be assessed, that can assess against that learning. And these two links in the middle are actually hyperlinks which link to the senior secondary TKI guides, which has a load of really fantastic stuff. They were developed through the realignment process 12 years ago. And because until at least 2025, we are officially against the current curriculum, our level 6 achievement objectives, the material we can use to teach, the context elaborations are all contained in these fantastic links here, okay? Now, to get a hold of your own copy there, those tiny URLs at the top of that text box, they will link you to a Google Doc, and if you download it as a Word document, you will get a copy of that screenshot you see at the top left. And I've seen HODs print these out and move the text boxes around and where they want to teach certain parts of content and idea in term 1, term 2, term 3 and term 4. I've seen HODs use them electronically. So the idea is to move around and construct a course of learning through the 4 terms that suit your school and your community. At the bottom there, the two URLs in red there are from Katie at Aquinas College in Tauranga, one of our pilot schools. There's an activity there she used to construct her course, which is a Desmos activity, the level 1 brainstorm. And the Aquinas outline is her course outline. And you'll see the thinking of a current pilot school, how they constructed their course and what assessments of learning they're thinking of doing, which drop out of that course of learning. One of the bits of feedback from HODs around the country, there's way too much to teach here in just one academic year, 4 terms, okay? The idea of the learning matrix is that is the learning which is too important to be left to chance. So we are sort of moving to a point where we're teaching the whole level 6 curriculum. And a number of HODs have got in touch with me, particularly quite recently, and said, look, we're thinking of making our level 6 course a 5 or 6 term course. So maybe some of the more accessible ideas in these achievement objectives in our learning matrix, some of those are going to be taught at the end of year 10. Perhaps, as I've mentioned already, trig and Pythagoras, and some of those earlier ideas in statistical exploration and statistical inference are going to be brought into their year 10 programs of learning. Just as an example of a school, a good mate, Hannah Reid, who's head of maths at Hamilton Girls, this is how she said she's been thinking for her courses next year. So she's got the entire learning matrix and the content of learning for level 6 for a year 11 program of learning. And I've deliberately got 2 screenshots there, and she's put together 2 broad courses which both cover the entirety of the learning at level 6. Now, I've called these Course Alpha. The left-hand one is Course Alpha from School XYZ, but as I said, Hannah deserves the credit for this. So it's actually from Hamilton Girls. There's one course from Hamilton Girls and another broad course, which in this case I've called Course Beta. I'm not sure what Hannah's called it, but she has 2 broad courses, which covers all the learning matrix content. And of course, what we're good at and what we always aim to get better at is that each course will be differentiated appropriately. The left-hand course probably could be seen as the slightly lighter, less in-depth, less enriched, less accelerated course. Perhaps less focused on the abstract and the algebraic content. What's going to drop out of that course are the assessments of learning, the explore data, the mathematical methods, and maths literacy and stats literacy 1.1, 1.2, and 1.3. Perhaps the right-hand course, Course Beta, covering again the whole learning matrix, but differentiated appropriately. The 3 assessments that are dropping out of there are 1.1, 1.2, and 1.4. The 1.4 being that end of year traditional maths exam, the pure mathematical reasoning one. Crucially though, and Hannah really paid some focus when she was sharing this idea with me, is that there is going to be some agency and discussion with the girls and their teachers and perhaps home as well. that the girls in each course may be able to swap between 1.3 and 1.4, okay? That some girls who may decide that they need a slightly more focus on some algebraic content and some of those high-level abstract ideas may switch into the 1.4 traditional end-of-year mathematical reasoning exam at the end of the year to assess the learning, but they have been exposed to all the learning. That's crucial in what Hannah's thinking, is that all the girls have been exposed to all the thinking there. Just wary of time here, so I just want to move past that slide, and I think it will be self-explanatory when you get the copy of this presentation. I wanted to share an idea which has been forming in my head over the last 2 weeks in particular, to do with a statistical activity using, I think it's relatively unknown. A lot of people have heard of it, but not many people that I've spoken with in the last 2 or 3 weeks have used this tool. And it's linked to an idea to do with time series, when we're eventually thinking of assessing our learning on the statistical front against 1.191944 explore data. So I just want to show and share and put my passionate math teacher hat on, if that's okay, about a statistical activity which can be unpacked from our learning matrix. So there we go, our whole year's worth of learning, the whole significant learning and achievement objectives from our learning matrix at level 6. And the focus is on those 4 little text boxes there, which if you group those together, the PPDAX cycle, the sourcing and interrogation and collecting and using multivariate data sets, the asking of a question and using appropriate data visualizations, and then the description and the explanation of features and trends and other contextual features within data sets, packaging those 4 text boxes together, that's a large chunk of our teaching and learning of statistics and data handling, okay? And what I wanted to do was link that in with an example of where we can get our kids to explore and get their fingers and toes dirty with time series. I've had some really interesting feedback from colleagues in the last 3 or 4 weeks saying, from pilot schools, saying it was such a shame we weren't able to do time series. The pilot schools, as you may be aware, are constrained somewhat, so they have to use tasks which are the ones up online. But the feedback I've got is, hey, time series would have been so cool to do with our classes, because it's a really good low floor, high ceiling activity. Okay, it probably has that greatest accessibility, and then can go really in depth towards the end, and probably too much beyond level 6. So perhaps some care and attention needs to be had there. The learning that gets assessed at the end is against the achievement standard 1.191944, and I have always been really taken by that word explore at the start of the title of that achievement standard, and then linking that back to our teaching and learning, which is the driving force, our teaching and learning. How can we get our kids to do some exploration? And as Robin said earlier, and Brad as well, they're going to make some mistakes. They're not going to hit the mark of some of their exploration, but by doing that exploration, they start to develop their own journey, their own agency, and they start to develop their own narratives with evidence and some good contextual statistical thinking. So just to briefly show you an activity I've been working on and thinking about in the last couple of weeks. Gapminder, I won't do a quick poll that I had planned to say how many people have heard of and or used Gapminder, but Gapminder is a fantastic tool, and particularly that animation section is something which really could link in, which eventually could be used as an assessment of learning against 1.1 in the time series context, which, as we may know, is one of the 4 investigation situations that kids should be exposed with and taught and learned through their teaching and learning of stats. And the idea here in using Gapminder was generated and created by Hans Rosling, a Swedish statistician, and that's just a screen clipping of a very famous BBC video, which really does highlight all the fantastic work and ideas that Hans Rosling did with Gapminder. And the idea here, very briefly, that I'm going to show you, time is our greatest enemy here, or more like my waffling on too much before I hand over to Edwin, is, can we start, when we're doing an exploration of statistics, can we start with something which is very broad, perhaps student-led? It encourages the kids to dip their toes and fingers through an exploration. A very cool teaching and learning activity, broad to start with, which can become quite more specific, because as teachers, we know we have a professional responsibility that this eventually is going to be assessed against 91944. But can we just start with some, right at the start, our teaching and learning, very, very broad, give the kids some agency. And so there's a contrivedness to this context here, but what about a broad question like, well, sir, miss, I'm reasonably interested in, look, what's been happening with worldwide trends in aspects of maybe economic, social, educational data worldwide, which is particularly what Gapminder is good at exemplifying through their data sets and visualizations. Now, eventually, when it comes to meeting the standard, and when it comes to that assessment of learning which drops out, the question needs to be quite specific. And I know most HODs now have had Pip Arnold's book land on their desk, which has been sent out by NZAMT. Pip's book has good sections on the specificity of the questions for each of those investigation situations. So eventually we may lead to this specific question here. As it says in red, what are the patterns of the number of years females have spent in education across those 6 countries there, okay? And before anybody points out, I've definitely spelled Australia correctly there. So if we wanted to compare across the last 50 odd years, that particular question, that's perhaps a way we could frame that question after starting very, very, very broadly. Okay, so let's just get into Gapminder and show you very briefly what I'm thinking of in regards to this activity. So this is the front page for Gapminder. And if we scroll down to the animations section, and then within the animation section, if we go on to trends, and one of the requirements when it gets to the assessment of learning, but not at the stage you're getting kids and yourself to play and explore and get their fingers and toes dirty, one of the requirements of the standard eventually will be multiple visualizations. Well, if I just click off, well, it was the USA I wanted to click off Russia, Nigeria, China. I just click on those other countries, which was Canada, New Zealand. There is a reason why I want these 6 countries, as you'll see when we start to compare. And the UK, I think I might have missed out Australia. Can't miss off the Aussies. There we go. And then if I click up here on the left, and I was particularly interested in education and the mean number of years in school for, let's say for women from 15 to 24 years. Okay, well, that's stuffed up. There is a reason why I want those 6 countries. I should have done that the reverse order, but I can click Australia, Canada, and New Zealand. And I'm going very fast here, and I'm probably mixing up the teaching and learning, and we're thinking in the background, eventually the assessment of learning is going to drop out of this. The UK is further down, and I'll click those countries. Even then, I think I've missed well, no, I think I've got all the countries there. And the coolest thing you can do in Gapminder in trends is that we can adjust the speed here, and I'll take it down to a little bit slower, but we can start the animation and the time series here and the trends of the mean number of years the girls have spent in education up to the age of 24. We can start the animation there. And I've actually shared this idea with Pip Arnold a few weeks ago, and she made a really good point. How cool would it be? It doesn't just have to be a written report. How cool would it be, sort of an audio-visual podcast? The kids are stopping there and they're discussing what's happening with the data and the mean number of years the girls have spent in education there. India is a very interesting one, which I just want to add in here. Right there. So it gets us our 6 countries. India started very, very low. We've got 6 countries on there. And one of the things what I'm exemplifying now will do, one of the requirements, which perhaps the pilot schools are thinking, this is one of the constraints in the standard. One of the requirements in the standard for exploring data 1.1 is to have multiple visualizations. We have multiple visualizations here. We've got 6 time series on 1 set of axes. There is enough here to cover that multiple visualizations, but we can click on the play and we can see what's happening. We can, through all our cool teaching and learning through that investigation situation of time series, we can get them to talk about the accelerated rate of the number of years girls in India are now spending in education and school from a very low base. We can talk about the odd shape of the USA curve. It's got a non-linear trend almost, because it starts at the highest and then plateaus and now is starting to increase again through to the last 10 years. So we can do all of that very, very cool stuff. And if we're wrapping it into eventually a project, which could be assessed against 1.1, an assessment of learning, we might, a particular student might get really interested in what's happening with India, and they can click off this variable and go into the economy variable, and they can go to the GDP of India. GDP GNI, as it's called now, gross national income. And they can talk about, well, there's this other linked variable, which I can see over time, that India's gross national income has increased, and which one's explaining which. If we're keeping our girls in school for longer, hopefully as long as the males that have that chance in school, we can see an increase in GNI, but which way is the right order there? So now we can quite see how we can get into some extended abstract statistical thinking, wrapping in some other variables and other contexts, which I think we'd all agree really is a very, very good level at level 6. So I just wanted to share that activity specifically with time series, because that's some commentary from the pilot schools in particular. They felt it was a shame they couldn't do some time series with their assessments of learning. You may have picked up on the left-hand side, initially, quite often Gapminder uses a log scale, but you wouldn't ignore the opportunity to perhaps discuss the log scale with the kids there in class. But it's easy to change that to a linear scale, and obviously that just changes the look of the curve quite significantly. India's GNI per capita is still dragging along quite close to the x-axis there. So this presentation will be available. I need to quickly hand back to Edwin, because he's got a fantastic mathematical one. The last thing from me is that Pip and I did work on putting together a package, which, if you click on this URL, tiny URL, year 11-stats, it does have some wonderful planning and resource ideas for planning the whole teaching and learning side of statistics at year 11 against level 6 of the curriculum. So if you wanted to get in some planning quite soon for next year and our courses in 2024, Pip especially has put together a fantastic resource there. Okay, sorry, Edwin, 3 or 4 minutes too long, but it's over to you now, my friend.
All right, let me just share my screen. Sorry, just give me a minute. All right, can you see my screen or not yet?
Not yet, Edwin, but
Okay, sorry, this is the, yep, should be able to see that now.
yep, it's coming. There it
Okay,
is.
okay, great. Now we've heard about the challenge of not presenting math in a siloed way. And we've also heard that a lot of the learning, that all of the learning in the learning matrix is crucial for us to cover, and especially because of the spiral nature of math learning. If you don't cover particular strands and topics at one level, it makes it really difficult for students to progress to the other level. So I want to show you an activity that I've trialed with my year 12s and brought it down to my year 11s to hopefully kickstart some thinking in that area. So making the link. So we're looking at combining strands in one learning task. So if I were to bring these numbers to you in a table, I'd be asking a class, what is it that you observe in this list of values for X and Y? And rather than pause to let you do it because of time, I'll just show you some of the feedback that I've gotten from my class. After a couple minutes of looking at it, some of the things that I hear is, well, as the X's increase, so do the Y's. And we just had a session first thing this morning on proportional thinking. And I think that fits in perfectly there. All the decimal places in the Y values, one student was very intuitive, very shrewd with this one. All the decimal places in the Y values tend to suggest that they're the result of a calculation and not just a measurement, which I thought was a really good observation. But it's hard to tell if the increase is proportional because the X's are not at regular intervals. And actually I did that on purpose because I didn't want them to spot the proportion to, sorry, there may be some noise in the background. I didn't want them to spot the proportion too easily. Now, when we look at numbers, and this is a nice crossover between mathematics and statistics, when we look at numbers, we want to see if there's any relationship between them. The thing is, the more numbers we have in a table and the more complex the numbers look, it may be difficult to spot that relationship. So the question I ask is there an easier way to see the relationship or the pattern? And someone eventually says, let's draw a graph. And when we draw the graph, I used Excel to draw this. This is what we got. And what do you see from the graph? Well, there's a linear relationship. And because of that linear relationship, there seems to be a proportional increase between X and Y. Now, then I dropped the hint to them about this data actually representing a shape that we've studied. And when you see a straight line graph, what's the first thing that jumps out at you? Gradient, intercept, equation. So we calculated the gradient. Some of you may notice that I fudged the rounding off just a little bit, and that's just because I wanted them to be able to recognize the gradient as a particular value. The intercept is 0. So the equation comes out to y equal 3.1416x. Aha, someone in the class says, that number looks really familiar. It looks like pi. So the equation is y equal pi x. Well, does this look like any shape that we've studied? And sure, it looks like a circle. It looks like it could be the equation of a circle. Well, what property of a circle? Circumference. So we've established that there's a linear relationship between the circumference and the diameter of a circle. And we've looked at it in terms of a table, a graph, and algebraically by an equation. So we've established, as I said, that it's a circle, X, so we go on to discuss, since this is a circle, what X and Y represent. Of course, X represents the diameter, Y represents the circumference. What happens to Y if I double the value of X? Well, the question the answer I'm searching for there is, well, if I double X, I should also double Y. How would you know that from looking at the graph? So again, appealing to the proportional increase, the linearity of the graph. Now, then step it up, make it a little bit more difficult. This one, I tell them at the beginning, well, this one represents a calculation from a shape as well. And again, what do you understand? What do you observe, sorry, about the values for X and Y? I get a lot of answers like, oh, well, they go up really quickly. And again, because of the amount of decimal places, it seems that there's some calculation involved, but they really seem to go up quickly. Between X equal 1 and X equal 2, it's only a difference of like 38 points. But then when you go from X equal 10 to X equal 11, it's almost 300. So class, what do you expect the graph to look like? Do you expect it's going to be a straight line? Probably not. So let's draw that graph using a graph software and see what happens. And that's the graph that we get. This being level 1, they would have been familiar with parabolas. So someone is going to say, okay, this is a parabola. And let's have a look at trying to get some of the properties of that parabola. I've asked them to describe the graph, what's different from the first one. And yes, it's not a straight line. And we know that once we want to identify the equation of a parabola, we need to look at the first difference. And again, because this first difference is not constant, it gives a numerical interpretation of what we're seeing visually on the graph. So then we look at the second difference and we see, aha, the second difference is constant, which verifies that what we're looking at is an X squared parabola. Because remember, it's a curve, but at that point, we don't know if it's actually an X squared or X cubed, or any polynomial curve. So we take them through the algebra of working out the equation of that parabola. We know that it's ax squared plus bx plus c, where 2a is the second difference. We've calculated the second difference. So we got that a is 12.566. And then we can use 2 points. Obviously, we use the two easiest points. One where x equal 1, we get that equation b plus c equals 0. X equal 2, we get 2b plus c equals 0. And we solve those as very easy simultaneous equations. And that's our equation. Y equal 12.566 x squared. Sorry, I'm going quite quickly because I do know that time is of the essence. So again, does 12.566 look familiar? Well, in the first case, when we got out the gradient of that line, it was pretty easy to see that this was pi. But looking at 12.566, it may not immediately ring a bell. So after some discussion, one student took a calculator and divided it by 2 and got something that looked vaguely familiar. So he kept dividing it by 3, divided it by 4, and he found that it was 4 pi. 12.566 was 4 pi. So we came to the conclusion that the equation of this parabola was y equal 4 pi times x squared. So what shape was it? And what was I calculating? And what do x and y represent in this case? When I did this with my year 11, there was a really involved discussion in terms of, is it a plane shape or is it a solid? And why do they think it's a solid, etc. Some really rich discussion in class. So we came to the conclusion finally that we were looking at a sphere, and it was the surface area of a sphere. So again, for further discussions, if I double the radius x of the sphere, because we decided that x in this case was the radius and y was the surface area. So if we double the radius, what happens to the surface area? How is this shown in the table, on the graph, and in the equation? And then we try to extend that thinking. What would happen to the volume of the sphere if we double the radius, and why? Because at every step, what I want to do is to connect what you see in the table with what you see on a graph and what you see in the algebra. So what we're aiming for is that, okay, if I double the radius, it actually multiplies the surface area by 4 because it's an x squared. But then what happens to the volume? Well, the formula for volume of a sphere has an x cubed. So it would multiply it by 8. So the moral of that story is when you look at just that one activity, what it has touched on from, this is the new 1.4, which will be an external. And this is a screenshot of the assessment conditions. You can see that some of the things that we touched on, manipulating and simplifying expressions, quadratic equations, or more to the point, quadratic expressions, simultaneous linear equations with 2 unknowns. This was quite an easy one to solve, and that was on purpose because baby steps. Relating graphs, tables, equations, and patterns. Rates of change, looking at the gradient of a graph. And of course, we looked at the surface area of spheres, and we extended that discussion into things like the volume of a sphere. Why is it that we talk about the gradient of a line, but we can't really talk about the gradient of a curve per se? And just trying to get that link between geometry and space and number and algebra. And that's the end of my presentation.